This is the first video going over Chapter 11, Behind the Supply Curve, Inputs and Costs. This first part is going to go over and define what a production function is, and go over an example that if we were in a face-to-face class, we would actually do the example. Excuse me. Second part, which is not this part, right? We're going to go over and define what fixed costs are, variable costs, total cost, marginal cost. Third part, we're going to analyze how to maximize profit, which we've already talked about in Chapter 9. Keep producing as long as marginal revenue, the marginal benefit greater than marginal cost. And then the part 4, we're going to identify and calculate average costs and what we might do with those. This chapter is by far the most practical thing to understand, in my opinion, in microeconomics, especially if you hope to be a financial analyst or something like that. When I used to do that for a profession, identifying or evaluating whether you can think like this chapter, right? Think in the ways of this and use these concepts or these types of concepts to do analysis is exactly the type of skill that I would be looking for to see if I might want to hire you, right? So with that, let's get started. All right, put this lecture aside. Okay, so as I mentioned, this first part is we're going to kind of play a game. We would be playing the game in the class, but right now we're just going to describe how that game works, and effectively we're going to make quote-unquote books. And this is the first part of Chapter 11 in the recruitment text. Okay, so this production of books game, right? So the assets, right? The equipment, property, plant, and equipment that we have to make books. We have paper, that's our inventory, right? That's actually our materials. We have an unlimited quantity of paper and staples, by the way. We have one blue pen. We have a stapler, and we have a desk, okay, where the desk is the factory, such that all the production that happens has to happen on the desk, right? This would work so much better, right, if we were actually doing this in the class, but imagine this scenario, right? Imagine there are all the students who are part of the company producing books are sitting around the desk with this equipment and these materials, okay? And we're going to do this production, or imagine at least doing this production in with different levels of workforce, different size of workforce, different number of workers. So first, the way we're going to make the books, first we're going to fold a piece of paper in half. So take a 11 by 8 by 11 piece of paper, fold it in half, then fold it in half again. Then we're going to draw the following on the cover: NY. We're going to circle the NY on the cover. On the inside of the book, we're going to draw a B, and we're going to cross out the B. What do you think, New York? What do you think, New York? What do you think NY and B stand for? Damn Red Sox. And after that, we're going to staple the top corner. So to imagine this better, I encourage everybody to get out a pen, get out a stapler, get out a piece of paper, fold the paper in half twice, do the writing as described here, staple it. That is the production of one book, right? And what we're going to see is how many books we can produce. Oops, that's kind of off the screen. So see how many books we can produce. We're going to put the books, when we're done, in the finished goods inventory. Okay. So each round, when we did this in class, right, averaged 90 seconds, right? So we spend 90 seconds of a production. Imagine that's a day, right? First, I did it by myself, right, and was able to produce some number of books. Then two students came up and discussed, strategized how they were going to split up the work, right, and then tried to see how many books they could produce. Then 3 did the same thing, and then 4 did the same thing. So if we did this in class, we'd actually be able to come out and fill in this table where we have each number of workers, how many workers there are, and how many books in that 90-second period that is meant to represent a day they were able to produce. Right? This is basically a production function, right? This shows us, and this was actually approximately what happened when we did in class on average. So obviously, if there's no workers, no books were produced. One worker, I was able to produce 5 books, 2 workers 10, 3 14, 4 16. Okay, so this is a production function. So that's one thing to recognize. Production function shows us the relationship between some quantity of variable input. In this case, it is the workers, right, that we are varying, and how much output, the quantity of output, in this case, books, we're able to produce. So this is a production function. Okay. So as we add workers, what happens to the level of production? Well, as we can see in this table, and as would hopefully logically make sense, the production increases, at least for a while, right? At least for adding some number of workers, which we'll kind of expand upon and think about that more deeply a little bit later. Now, the question is, we want to be able to quantify, well, how much more output are we getting every time we add a worker? Okay? And that's going to have a term. Every time, so we're looking at how much output changes. Anytime we're analyzing any variable that represents change in economics, it's a marginal variable, right? In chapter 9, we analyze marginal cost. How much does cost change when we produce one more? We're going to talk more about that later in this chapter as well. But right now, we're not looking at the dollars it costs to make the book. We're looking at every time we add one more worker, how many more books can we produce? So the marginal product of labor, because that's the input that we're varying, is as we add workers to a factory, and big asterisk here, with a fixed amount of equipment, right? How many extra books can we produce every time we add an extra worker? So if we define, right, making it a formula, right? Delta, often the symbol representing change, the change in quantity of output, delta Q, change in quantity of workers, delta L. So the marginal product of labor is the change in quantity of output, i.e. in this case, how many more books can we produce as we add workers, as we change the number of workers. Okay. So let's add that to our production function table. Right, so there's the change in quantity of books divided by the change in quantity of labor. Now, please note this is an incremental thing, so it's step by step. So there's going to be, it's how much more is, in this case, is each extra worker helping us produce. Right, so that's the marginal product of labor that we just defined. So question, what is the marginal product of labor in this example, in this production, of the third worker? Think about that for a second. Now, some of you might be sitting there thinking 14, because you look 3 workers, 14. But that's not the marginal production of the third worker, right? That's the production of all 3 workers together. To get the marginal production of the third worker, we have to look at, well, how many more can the 3 workers produce than 2 could produce, right? Remember, it's the change in quantity of output, in this case, 4 books, divided by the change in number of workers. In this case, the change is just 1, so 4 divided by 1 is 4. So as we look at this production function, what happens to the marginal product of labor as we add workers, as we add the third worker and the fourth worker, as compared to the first and the second? Well, we can calculate that, and what we're going to see is that it decreases. Right? In this example anyway. Right? So first worker, right, that was me, right, producing books. I was able to produce 5 books, which is 5 more than if there were no workers. Okay? So that was a marginal product of labor of the first worker of 5. Now notice how I kind of indent that number so I don't put it on the line equal to, on the same line as the 1 worker and the quantity, right? I kind of put it half in between, right? 0 workers and 1 worker, between the quantity of 0 and quantity of 5. Well, that's because it represents change. That's often how it's represented in text and tables, just to kind of highlight the fact that it is moving from here to here. How much is changing when you're moving from 0 workers to 1 worker, producing 0 books to 5 books. So, okay, so then marginal product of labor of the second worker, another 5, right? Because it increased from 5 to 10. And then we already talked about that it's marginal product of labor of the third worker, it increased by 4. And then the marginal product of the fourth worker increased by 2, i.e. it is decreasing. So how can we explain why that might make sense? How can we explain why the marginal product of labor might in fact decrease as we add more and more, in this case, workers? Well, how can we explain the pattern? Well, there's a concept that happens often enough in a production process like this that there's a term for it. It doesn't always happen, but it happens often enough. And it's known by different things. Sometimes it's the term is diminishing marginal product, sometimes diminishing marginal returns. But the main idea is if you're adding more and more of a variable input, like in this case workers, to a fixed amount of capital, i.e. a fixed size of factory, a fixed amount of equipment, the marginal product of labor usually starts to go down at some point. Now, why, again, still haven't answered the question. That's just putting terms on the question from the last slide. Well, why is that the case? Because there's only so much equipment to go around, right? There's only so many unique steps in any production process that you can split the work between workers. And once you've split the workers as much as you can split it up, at some point you really can't, each extra worker helps you produce less and less extra output. So for example, for this production process, anything above 4 workers likely adds little or nothing to production, right? If we were to go to the 5th worker, maybe the marginal product is even 0. And why is that the case? Well, just think about the steps in this process. So you have folding. You know, first someone could be folding, maybe even have 2 people folding the piece of paper twice. There's only 1 pen, right? That's that piece of our equipment. Right? That's one of our pieces of capital. There's only 1 pen, so adding a second person to do writing doesn't make any sense in this factory with this amount of equipment because we only have 1 pen. So only 1 person could write. Really, only 1 person at a time, right, can staple, and that's the same for pen, right? 1 at a time. So at most, you could probably have 4 workers being productive. If you had a 5th, I guess maybe you'd be able to have a 3rd person folding, but that the person writing would probably not be able to keep up, right? But at some point, definitely not, 3 or 4 or 5. At some point, you're going to not be able to split up the work anymore. So it's going to cause this dynamic. It's going to cause additional workers to not help you produce more. Right? So so that's the concept of diminishing marginal product, diminishing marginal returns, and the returns is the benefit of adding the workers. Okay, so a production function, in addition to being represented in a table as we did before, or as we show also here, we can also represent the same information on a graph, right? Where the first column, right, number of workers is on the horizontal axis. The second column, the quantity of output of books, right, is on the vertical axis. And we'll talk about the marginal product, how we see that in a second. Okay. So what we're going to graph basically is the first 2 columns here, right? Number of workers, which is on the table, or in the graph, and the quantity of output. So if we have 1 worker, quantity of output is 5, so that would be 1, 5, right? 2 workers, quantity of 10, 2, 10, 3 workers, quantity of 14, 3, 14, and 4 workers, quantity of 16, 4, 16. Okay. Now, typically this isn't going to show up as dots like this, but that's literally what we're graphing. Usually it's just going to be a line running through, or a curve running through those points that we just graphed. Okay. Now, how on this graph do we see the marginal product of labor. Because it's not literally or exactly on the graph, right? Like the workers are on the graph and the output is on the graph. Remember, though, that that's the same variables, but we're looking at the change in those variables, right? So the change in quantity, the change in the vertical axis, divided by the change in workers, the change in the horizontal axis, change in y divided by change in x. Hopefully this is starting to sound familiar. Rise over run, it's the slope, right? So the slope of the production function is the marginal product of labor, right? So the slope from 0 to 1 worker and from 1 to 2 workers is a slope of 5, right? So, and then it's going to get less steep as we go, right? Because the marginal product of labor of the third worker is only 4, and then only 2 for the fourth one, and it might be 0, right? If we have 5 workers, maybe that extra worker doesn't help us produce anymore, so maybe this was 16 again, so it'd be 0, and then this would just be flat. Right? So it's the slope of the production function, which is an important thing to recognize. Is marginal anything is always a rate of change of the total thing. So marginal product of labor is the rate of change of output as we add workers, right? Which is what a slope is. Now, what if we wanted to increase production above 16 books per day, or per this 90-second thing, right? What if we wanted to be able to add a 5th worker and a 6th worker and a 7th worker and still be able to increase production? How could we do that? Well, hopefully logic would say we need to add more equipment, right? We need to, in this case, have another pen, have another stapler, such that we could have 2 people writing and 2 people stapling, and then you could have maybe 4 or 5 or even maybe 6 people folding. Right? So that concept is talked about in the book, right, in figure 11.3, which basically says, hey, my production function, they call it a total product curve, right? Same thing that we just drew here, production function. If we add equipment, right, we can shift that production function up. We can increase the amount that each additional worker is helping us produce and let us add even more and more extra worker, right? We can add equipment. And that's basically all this is showing. At this point, don't worry so much about the marginal product curve on the left, but just recognize this idea. So this is basically just saying, hey, we're adding workers, and that's how we can shift the production function. Right? We can get more productive with more equipment. This is a concept that we talk about, or that is talked about a lot as well in an aggregate sense in macroeconomics. Okay. So that is the end of part 1, and the next video we'll go over part 2, start talking about different types of costs.